Today start with the new subtopic for that shift registers. What is a register? I think in one of the previous classes just we spoke about the register. What is the register here now? Not the 1 kilo, 2 kilo registers talking about. What is that? Before this we have discussed the flip-flops and all. What is a flip-flop?
1 bit memory.
Is that? This is because we store a single bit, either 0 or 1. If you want to store 4 bits, how many flip-flops should you use? 4. So it's called the 4-bit register. To store 8 bits, 8 flip-flops. So it's called 8-bit register and so on. So in general, what is a register now? It is a group of flip-flops used to store group of bits. Okay. So accordingly, there are 4-bit registers, 8-bit registers, 16-bit registers, and so on. These are the integral part of the CPU of a computer. So CPU stands for central processing unit, right? In that, so to process the data temporarily, or to there, for example, we have to add 2 numbers. During at the time of the addition, those 2 numbers should be in registers. Then later we can transfer it to memory or something else. So for usually all the data will be stored in the memory. From the memory we take the numbers, which are the numbers to be added or subtracted, whatever it is. So we can transfer one number from one location to another location and so on. But all these are going to happen through the registers in most of the cases. Okay. So right now, what is the register now? It is a group of flip-flops used to store group of bits. So and we call this what shift registers because we can transfer the data or shift the data inside the register as well as outside the register and to shift the data from one register to another register, register to memory, memory to register and so on. So these are what the shift registers. There are different kinds of registers what I have written in the block diagram. These are the block diagram of the different registers. So this depends on what the arrow notes what I have written, the data flow. Okay, how the data can be entered into the shift register and data can be taken or retrieved from the register. Depending on the different ways, we have the different types of registers. Say for example, in a single bench, how many people can you sit? The 4, maximum 4. Suppose how to sit? Come here and sit down. It is fine. But we have to control the operation of this sitting. Say when I say 1 person should come here. When I say 2, that person should come to the next position, another person should come here. Okay, 3, 4. How many numbers should I tell to make you 4 people to sit? 4. 1, 2, 3, 4. After when I say the number 4, all will be in the position. Again, you have to come out. Again, that can be controlled. When I say 1 again, so like this. Okay, so this is what the one way of sitting in and coming out. Okay, this is called serial in, serial out. One after the other is what? The serial in, serial out. Other kind is what? Serial in, parallel out. Serial in is sitting one after the other. Parallel out is coming out, jumping from the bench simultaneously. Serial in, serial out. Sorry, parallel out. The other one is what? Parallel in, serial out. Sit one time and go out in one after the other. That's what? Parallel in, serial out. Other one is what? Parallel in, parallel. Jump in, jump out. So here also, we try to transfer the bits into the register. Say we will discuss the 4-bit register. Each box will indicate the flip-flops like this inside. Okay. So this is what serial data in. Serial data in. This is what serial data out. This is called serial in, serial out shift register. That is SISO register. Serial in short we call it as serial in, serial out shift register. Okay. And this is what serial in data. This is what parallel out. Parallel data out. This is called what? Serial in, parallel out. SIPO in short. Can you guess now? What is this now? Yes? Parallel data in. This is serial data out. So in short what we call as parallel in, serial out, PISO. Parallel in, serial out. What about this last? Parallel data in. Parallel data in. Parallel data. So here the diagram. These shift ratios are going to be built by using the flip-flops what we discussed so far. Okay. So for this shift register, most of the time we use either SR flip-flops or D flip-flops. You can use either SR or D. So this is a diagram using the SR flip-flops with a small modification. So the title for this is what? Serial in. Serial in, serial out. Shift register. Serial in, serial out. SISO register. Okay. So this entire thing will be inside the register. So as I said, for a serial in, serial out shift register, only one input will be there and only one output will be there. And I gave the analogy to enter into the bench and to come out of the bench. How? When I say the number, then only I have to enter. There is one after the other. Here also, the shifting of the students is going to be controlled by what do you want? What do you want? Controlled by the number what I say, right? 1, 2, 3, 4. Here also, the shifting of the bits is going to be controlled by the clock pulses. After one clock pulse, after second clock pulse, third clock pulse, and so on. Okay. So when one clock pulse is applied, one bit will be entered into the and that will be shifted to the other. That will be shifted to the other, and so on. This is the way how the data is going to be entered here. Now we know the two type of the SR flip-flop, D flip-flop, and so on. Okay, this is the clock, this is clock, this is clock. What kind of SR flip-flops these are? We have the different kinds of SR flip-flops. What are those? Level triggered, positive edge trigger, and negative edge trigger. What kind of flip-flop these are? Positive edge triggered SR. We know the two type of the SR flip-flop also. When both are 0, 0, no change activity. Okay, 0, 1 reset. 1, 0 set. 1, 1 is forward direction. So here what we are going to do, the outputs of each flip-flop, that is Q1 and Q1 bar are the inputs for the next flip-flop. Let's call these flip-flops as what? Flip-flop 1 or flip-flop A, anything we can call it. This is flip-flop 2, this is flip-flop 3, flip-flop 4. Right. Now, the outputs of the first flip-flop, that is Q1 and Q1 bar are the inputs for the S, second flip-flop as S2 and R2 and so on. But for the first one, what I have done, just we have connected one NOT gate between S and R. But it has only the single input data to enter the data inside. Okay.